Good morning. Welcome to the discussion of the operations on sets. Below are the sum of the following are some of the operations on the set and which are analogous to algebraic operations on numbers. That is union of sets, intersection of sets, complement of a set, relative complement, symmetric difference. In that, let us begin with the discussion of the union of sets. Consider two sets A and B, then the set consisting of all elements that belong to A or B is called the union of set A and set B and is denoted by the symbol A union B. Thus, A union B is equal to X such that of X belongs to A or X is an element such that it belongs to B. The Venn diagram for the union of sets is as shown below. That is, set A union with set B. That is, it is showing that consisting of all the elements. So the obvious result is that set A is the proper subset of A union B, and set B is the proper subset of A union B. Next, moving on to the discussion, intersections of sets. Given two sets A and B, the set consisting of all elements that belong to both A and B is called intersection of A and B, is denoted by the symbol A intersection B. This is how we are going to denote the intersection of sets. Thus, we are going to write it like this: A intersection B is equal to X is an element such that X belongs to set A and also X belongs to set B. Here we need to notice clearly that with respect to union we are going to use the keyword OR, and with respect to intersection we are going to use the keyword and hence the result, that is, it is obvious that A intersection B is the proper subset of set A and A intersection B is a proper subset of set B, and this is the Venn diagram with respect to the intersections of sets. That is, you are going to write the common elements with respect to set A and with respect to set B over here in the shaded part. This denotes the operations intersection of sets. Next, moving on to the next concept, complement of set. Given a universal set U, that is, this is how we are going to denote universal set, and set A contained in U, the set of elements that belong to universal set U but not to A is called complement of set A in U and is denoted by A complement, that is A to the power of C or else A bar. You are going to denote like this. Thus, A bar is equivalent to X is an element such that X belongs to universal set and X does not belongs to set A. The Venn diagram for this A's complement is as shown below. That is, it is same as that of the relative complement, that is, given two sets A and B and the set of all elements that belongs to B but not to A is called complement of set A relative to B or relative complement of A in B, and it is denoted by B minus A, that is, B minus A is equal to X is an element such that X belongs to B and X is an element such that it is not belonging to or it does not belongs to set A. That is how we are going to write. That is, B minus A means element should be present in B but not in A. In the same as while in the same case, that is, if you are going to consider A minus B, you are going to write the elements which are exclusively present in A but not in B. But if you consider B minus A, there also exclusively elements which are contained in B but not in A. That is how we are going to write in the, it is depicted in the Venn diagram. B minus A, that is the shaded part, the only elements that belongs to the set B apart from the common elements, and in the A minus B also, apart from common elements, you are going to write those elements which are exclusively belonging to the set A. Following are the few important results. The following results are obvious for any sets A and B. Sets A minus B and B minus A are disjoint. That is, A relative complement B and B relative complement A are disjoint. If A and B are disjoint, then A relative complement B is equal to A and B relative complement to A is equal to B. If U is the universal set and A is the subset of U, then U minus A is equal to complement of A, that is set A. And then if set A is equal to A union B minus B relative complement of A, then B is equal to A union B relative complement of A minus B. A is equal to A intersection B minus B relative complement of A. B is equal to A intersection B relative complement of A minus B. Next, moving on to the discussion of the symmetric difference. For two sets A and B, relative complement of A intersection B in A union B is called symmetric difference. The symmetric difference of A and B is denoted by this symbol A symmetric difference B. Thus, A symmetric difference B is equal to A intersection B minus A union B. This is how it is depicted in the Venn diagram.